me see. Pencil.
So if it can't go down, so would that be the answer too?
So it'd be that plus that is the remainder. Because since we have a quadratic, a 3-term is what we're dividing it by, we can have 2 terms as our remainder. Because with those 2 terms, the degree of what's on top is 1 because of the x. The degree on bottom is 2, so it works. Does that make sense? Yeah. 4, 3, 2, the second part with synthetic division, our remainders will only be a single number. The one 4, 5, but I think people have been snagging them extras.
Thank you.
So okay, good. Yeah. Whenever we do note sheets across multiple days, others have a habit of forgetting them and grabbing extras. And I only print off the absolute number we need, so someone normally goes without. So, before we get started, we are skipping chapter 4.4. We're not going to be going over it. Now, I did decide that 4.4 will be bonus points, so there is in Google Classroom the videos that are actually 4.4.4, part 1 and part 2. So if you want to go through those and watch those, do those, you can. The note sheets are on the bookshelf for those. So mainly it's going over factoring and the factoring theorem. Because I would have liked to have been able to cover those in class, but we just don't have the days to be able to cover it and everything else we need to cover and test in the timely fashion. But looking at 4.5, solving these higher degree polynomial functions. The first thing we need to do to solve any higher degree polynomial function is get the equation equal to 0. So the first thing we can do for this here is subtract 14x cubed from both sides. No, this is actually note sheets. Okay, you're good. So we get this here. 2x to the 5th minus 14x cubed plus 24x. That's right. Now we went over some of these yesterday that we could factor this, so we could factor out a common term. But we also went over graphing these. Now in the graphing calculator, we can hit y equals. And then we're going to type this in. 2x to the 5th minus 14x to the 3rd plus, I believe it's 28x, 24x. And when you get it typed in, hit graph. So when you get it all typed in, hit graph. When we graph this here, we see that it crosses the x-axis in 3 locations, which tells us, well, not 3, 5 spots. So there are 5 solutions to this higher degree polynomial function. And if we go second graph, it will show us some of the values. Because when we graph, what we're looking for, or what values of x make the y value be 0. And here we can see that we have one at -2, 0, and 2. So those are 3 of the solutions, but it does cross the x-axis in 5, so there are 2 others and we need to find them. So we use graphing to help us start this problem and find some of the zeros. And at this point here, we can use synthetic division to help us find the others. Because for each solution we have, we can use synthetic division with it to reduce the degree. Because if we divide it once, it's going to take it from a degree 5 to a degree 4. We do it again, it'll take it from 4 to 3, 3 to 2. So with these 3 here, we can take it from a degree 5 down to a degree 2, a quadratic, and we can solve quadratics. We've done those in chapter 3. Now the numbers going across the top, we'd have 2 for x to the 5th, 0 for x to the 4th, -14 for x cubed, 0 for x squared, 24 for x, and 0. We will bring the 2 down. And we need to pick one of these 3 zeros to try first. 0. So let's do synthetic division with 0. Well, 0 times 2 is 0 plus 0 is 0. 0 times 0 is -14 plus 0 is 0 times -14 is 0 plus 0, 0. 0 times 0 is 24 plus 0 is 0 times 24 is, and 0 plus 0 is 0. So it does work out, because if we have a remainder of 0, it means it's a solution. It means it works for our equation. All right. We can do it again, but let's try one of our other zeros. Which one do we want to try next? 2. And we'll do this again. 2 times 2 is 0 plus 4 is 2 times 4 is -14 plus 8 is -6. 2 times -6 is 0 plus -12. And lastly, 2 times -12 is, and 24 plus -24 is. So we have another remainder of 0, which means it is a solution. And well, they did give us one more, yes? -2. Because each time we do this division, we do decrease the degree by 1. So it's gone from a degree 5 to a degree 4, 4 to 3. And if we do this one more time, it will go from a degree 3 to a degree 2. Now, -2 times 2 is -4. 4 plus -4 is 0. -2 times 0 is 0. -6 plus 0 is -2 times -6 is, and -12 plus 12 is 0. Now we don't have any more zeros, or values of x that will make the function be 0. And if we wanted to, we could try 0, 2, or -2 again. I would not write this down, but I'm going to show you this here, because if I tried 0, 0 times 2 is, 0 plus 0 is, 0 times 0 is, and -6 plus 0 is -6. It gives us a remainder of -6. So 0 is not a solution twice. If we tried with 2, bring down the 2, 2 times 2 is 4, 0 plus 4 is 2 times 4 is 8, 6, negative 6 plus 8 is 2. It doesn't work. If we did negative 2, well, I'm going to erase this here so it doesn't get confusing. 2 times negative 2 is negative 4. 0 plus negative 4 is negative 4. Negative 2 times negative 4 is 8, giving us 2. So again, it doesn't work. So let's put our variables back in. 0 in the box is still the remainder. Our negative 6 is our term without x. 0 is our term with x, and 2 is our term with x squared. So it's telling us that we have 2x squared minus 6 is equal to 0. Well, at this point here, we can solve for the value of x by using our square root method. We could have also used the quadratic formula, but the square root method is a little bit more efficient and a little bit quicker. So we can add 6 to both sides. Our next step would be 2. Divide both sides by 2. 2x squared divided by 2 is x squared. 6 divided by 2 is. And lastly, we would square root both sides. Square root of x squared is x is equal to plus or minus, because whenever we take the square root of both sides, we have to add the plus or minus. And the square root of 3 is square root of 3. It doesn't reduce. So plus or minus the square root of 3 is 2 of our solutions. The other solutions are 2, negative 2, and 0. So for our degree 5 polynomial function, we got 5 solutions. Yes? Now I will show you kind of a neat trick. In the graphing calculator, go second trace. Second trace. Now the first one is value, yes? Hit enter. What this is asking us now is a value for x. So it will take a value for x and give us the y value. Now if we end up giving values too big or too small, it'll say window error, and there's ways to fix that. But we found one of our answers was positive square root of 3, yes? So we can do second square root of 3, and then hit enter and see what you get. And for the square root of 3, the y value is what? 0. Y is 0. Because again, what are we looking for? We're looking for what values of x makes the y value. So we have this here. And I could check second trace value negative second square root 3. Enter. It tells me it's also 0. So those two solutions do work. Questions on this here? Are you ready for the next one? Now we're going to skip ahead a little bit to this core concept, the rational root theorem. Now out of everything up here, this piece right here is the important part. Plus or minus p over q, where p is the factors of the constant term, our term without x, and q is the factors of the leading coefficient. And what this gives us is all the possible rational solutions of any polynomial function. So if we find these here, we find all the possible rational zeros for any polynomial function. So I would just write what's inside the box. Yes. All right. So we're going to find all the solutions for this here, but in doing so, the first thing we're going to find is our rational zeros, P over Q, where P is the factors of the constant term and Q is the factors of the leading coefficient. Well, Q is a little bit easier to find first, because leading coefficient is the number in front of the variable with the biggest exponent. And here, the number in front of the variable with the biggest exponent is 1. And P, our constant term, is 20. Constant term is the term without a variable, number without a variable. Now, the factors of 20 are a little bit more than 1, because the first ones we would have is 1 and 20. The next ones we have are 2 and then 4 and 5. So 1 and 20, 2 and 10, 4 and 5 are all the factors of P. Questions on this so far? So our rational zeros, we take all the factors of P and divide them by each factor of Q. So we're ready for the first one. So we have plus or minus. 1 divided by 1. Plus or minus 2 divided by 1. Plus or minus 3 or 4 divided by 1. Plus or minus 5 divided by 1 is 10 divided by 1. And 20 divided by 1 is 20. And with the rational zeros, all the factors of P will end up getting listed back out because we're going to divide them by 1 first. Now, if we had another factor of Q, say 3, we would repeat this process, but instead of dividing them by 1, we would divide it by 3. And we would continue on in such fashion until all the factors of Q have been exhausted. So, what this tells us is for this quadratic, or not quadratic, this cubic function, the rational zeros for it are either 1 or negative 1, 2 or negative 2, 4 or negative 4, 5, negative 5, 10, negative 10, or 20 or negative 20. So we're going to go this the pure mathematical way. The numbers across the top would be 1, negative 8, 11, and 20. We bring the 1 down. And the first possible rational zero we would try is 1. We would do 1 times 1, which is negative 8 plus 1 is 1 times negative 7 is 11 plus negative 7 is 4. 1 times 4 is 20 plus 4 is, so is 1 a solution? No, because the remainder is not 0. Okay. One didn't work, so now we can move on to what? 2. And we can do it again. 2 times 1 is negative 8 plus 2 is negative 6. 2 times negative 6 is 11 plus negative 12 is negative 1. 2 times negative 1 is negative 2. 20 plus negative 2 is 18. Okay, well that didn't work, so let's erase it. Then we can try 4. 4 times 1 is negative 8 plus 4 is 4 times negative 4 is negative. 11 plus negative 16 is negative 5. 4 times negative 5 is. And 20 plus negative 20 is. Well, so we know x is equal to 4. Now, if a number didn't work on the first one, it's not going to work on the next one. So since 1 and 2 did not work originally, they're not going to work again. They're not going to magically work now. As I can show you here, if we did 1 with this here, 1 times 1 is 1. Negative 4 plus 1 is negative 3. 1 times negative 3 is negative 5. Negative 5 plus negative 3 is negative 8. It does not work. We wouldn't get the exact same numbers with 2, but we would not get a remainder of 0. But we still have 4. It could work again. But we also have 5, 10, 20, negative 1, negative 2, negative 4, negative 5, negative 10, and negative 20. Because we have all these that we could try. Now, what I could also have done is taken this here, x cubed minus 8x squared plus 11x plus 20, and graphed it after we did this here. X cubed minus 8x squared plus 11x plus 20, and hit graph. I think I have a number off. X cubed minus 8x squared plus 11x plus 20. X cubed. I see what I did. 11x plus 20. Graph. We see that it does intersect at 3 places. Well, one of our solutions is indeed what? 4. What's another one? 5 and negative 1. Because negative 1. Because we tried 1, we didn't actually try negative 1. Because negative 1 times 1 would be negative 1. Negative 4 plus negative 1 is? Negative 1 times negative 5 is 5. And 5 plus negative 5 would give us 0. Now, if we put the variables back in at this point, remainder, negative 5 would be our term without x. 1 would be our term with x, telling us that the polynomial we have left is x minus 5. I can add 5 to both sides, telling us the last solution is x is 5, which is also what we found on the graphing calculator. Yes? Questions on this here? Questions on anything we've done so far? All right. We're going to skip ahead a little bit. Example 4. X to the 4th minus 11x cubed minus 42x squared plus 7x plus 12 is where we're at. Because what I'm going to do first is go on and graph it. So I would go on and graph this. And if we look at the graph here, we can see that it does cross the x-axis in 4 locations. So we do have 4 solutions. But do any of them look like nice numbers? No. And if we go second table, well, we saw that they were between negative 10 and 10, really between negative 3 and 3 is where all of them crossed, and none of them show up here. So the graphing calculator is still going to be helpful. The graph is still helpful, but it doesn't give us any answers outright. And this is where our rational zeros, plus or minus P over Q, really comes in and is really helpful. Now for this here on your note sheet, I would write it above the example that we're doing because we will need most of the space underneath to actually solve. Because I found out today, through most of the day, y'all ran out of space pretty quickly with this. Now the values of P. P is the factors of the constant term. Our number in this case is 12. So we'd have 1 and 12, 2 and 6, 3 and 4. Factors of 12. For our P, 1 and 12, 2 and 6, 3 and 4. I would write this above the problem. Because you might run out of room otherwise. Factors of Q. So we're looking for factors of what? Leading coefficient, which is 10. So we'd have 1 and 10, 2 and 5. All right. We ready to start listing off the factors of our possible rational zeros? Well, the first thing we're going to be doing is dividing it by 1. So we're dividing all the factors of P by 1. So 1 divided by 1 is 1. 2 divided by 1 is plus or minus 2. Plus or minus our 3 divided by 1 is 3. 4 divided by 1 would be 4, and we have our plus or minus. Then we'd have plus or minus. 6 divided by 1 is 6, and plus or minus 12 divided by 1 is 12. Now we move on to 2 and do the same thing. 1 divided by 2 is plus or minus 1/2. 2 divided by 2 is 1. Is 1 already listed? Yes. And if a number is already listed, we're not going to put it twice. So our 1 divided by 2 gave us 1/2. 2 divided by 2 is 1. 3 divided by 2 is 3 over 2. We'll try to keep these all in fractional form. Our next one would be 4 over 2, which is 2. We already have it. And we do 6 divided by 2, or 6 over 2, which is indeed 3. It's already listed. And lastly, 12 over 2 is 6. It's already listed. And the reason some of those did not have to be repeated is because, well, 2 and 2, 4, 6, and 12 all have a common factor of 2, yes? Do any of our factors of P have a common factor with 5? No. So it means with our 5, well, we're going to have to list them all back out. Because we're going to have 1 over 5, which is plus or minus 1/5. 2 over 5 is plus or minus 2/5. 3 over 5 is plus or minus 3/5. 4 over 5 is plus or minus 4/5. 6 over 5 is plus or minus 6/5. And lastly, 12 over 5 is plus or minus 12/5. So we also have to do it with 10. So the first one we would have is 1 over 10, which is plus or minus 1/10. And then we would do 2 over 10. Well, 2 over 10 is 1/5, so we don't have to list it. 3 over 10 is plus or minus 3/10. 4 over 10 would actually reduce to 2/5. 6 over 10 reduces to 3/5. And 12 over 10 reduces to 6/5, which we already have. So these here are the ones we don't have. And there's a grand total of 32 of them. But as we already saw on the graph, it does not cross the x-axis at any nice places. We did specifically look on 12 and negative 12, but none of these here work, which actually removes 1, 2, 3, 4, 5, 6, 12 of them, leaving us with 20. So we only have 20 left to look at. And if I look at the graph, there's 4 different spots where it does cross. And out of all of them, I'm going to look between 0 and 1. And out of all these here, I'm going to use a highlighter. The ones that are between 0 and 1, positive or negative, is 1/2, 1/5, 2/5. Apparently. Okay. 2/5, 3/5, 4/5, 1/10, and 3/10. These are the only ones between 0 and 1, positive or negative. And we do have a cross in both places, yes? Which one of these do we want to try first? We're going to pick 1/2. So in the graphing calculator, we can go second, trace again, and hit enter for value. Now it doesn't like fractions, so we'll have to put them in as division. So we can say 1 divided by 2 is 4.25, yes? So well, we can still try 1/2, but instead of positive, we will do negative 1/2. And well, it gives us 0, yes? So at this point here, we know that one of the solutions, x equals negative 1/2. Now we're going to apply it to our polynomial expression, and we're going to do synthetic division to reduce the degree from 4 to 3. If we can find another one, we can reduce it from 3 to 2 and solve the following quadratic. Now our negative 1/2 times 10 is negative 5. Negative 11 plus negative 5 is negative 16. Both of y'all, I want y'all to stay and finish this one out. If they do have issues, tell them they can call me, and I will, if they get upset, tell them to take it up with me. Now, at this here, negative 1/2 times negative 16 is 8. Negative 42 plus 8 is going to be negative 34. Negative 1/2 times negative 34 is going to be 17. 7 plus 17 is 24. Negative 1/2 times 24 is negative 12, and 0 plus negative 12 plus 12 is 0. Now most of these here, the multiplication and addition stuff, you can do in a calculator. It's going to be easier to do most of this, especially with our fractions in a calculator, than it is to try to do it in your head. So, negative 1/2 worked. Positive 1/2 did not. So looking at this graph, the negative one between 0 and 1 we've taken care of, yes? Which means all the rest of these here that we selected, being between 1 and 0, any of them that are negative are now out, because we already found it, yes? So we already know negative 1, positive 1/2 doesn't work. So we can move on to 1/5, yes? So I can do the same thing. Second, calculate value. 1/5. Does it give us 0? No. Second, calculate value. The next one was 2/5. No. Second, trace value. The next one was, and it does give us 0, yes? So the next value of x that works is 3/5. Bring down the 10. And we're going to do this again. And especially with 3/5, I would highly advise doing some of these calculations in a calculator, because 3/5 times 10 is 6. Negative 16 plus 6 is negative 10. Negative 10 times 3/5 is negative 6. Negative 34 plus negative 6 is negative 40. 3/5 times negative 40 is negative 24, and 24 plus negative 24 is 0. Now at this point here, we're going to plug the variables back in. I'm going to go on and tell you the rest of the rational zeros do not work for this here. We can try plugging them all in. None of them will work, unfortunately. Now there are two other solutions. It's that they are not rational, because our plus or minus p over q gives us all the possible rational zeros. If none of the rest work, it means the rest of the solutions are either irrational, they have a square root, or complex. Now, the last thing we need to solve is this here, 10x squared minus 10x minus 40. Now, if there is a greatest common factor between the three terms and it's a number, get rid of it. Here, is there a greatest common factor between 10x squared, 10x, and 40? 10. We can actually divide the whole thing by 10 and get rid of it. Now, if a variable is in common with every single term, we cannot divide it out because it's removing a 0 from the equation. And most likely it is a 0. It's actually 0. But this helps us finish solving, because now our numbers are going to be a little bit smaller and a little bit more manageable. Also, it means that there would have been a common factor of 10 that had to be removed later anyways. Now, to finish this up, we have to use the quadratic formula. Now, looking at this here, the value of b is -1. B is the number in front of x. Plus or minus b squared minus 4 times a times c. Questions on how we plug this in? Hopefully y'all remember this from 3.6 from last chapter. Now at this point here, -1 is 1. 2 times 1 is 2. Now at this point here, we can simplify what's inside the radical, or -1 squared minus 4 times 1 times -4. 1 squared minus 4 times 1 times -4, which is 17. Now we can take the square root of 17, and if we type it in the yellow calculator, the graphing calculator is going to approximate it. It actually tells us it's the square root of 17. There is no way that we can simplify it and leave it in radical form. So the other two answers are this here. So our four solutions for this here are x equals -1/2, x equals 3/5, and x equals 1 plus or minus the square root of 17 all over 2. Now I could check that value here, second trace value. I would have to put parentheses 1 plus second square root 17 divided by 2, and we get this here. Now, it doesn't specifically say 0, but 1.2 e to the -11 is just saying 1.2 times 10 to the -11, which is approximately 1, 2, 3, 4, 6, 7, 8, 9, 10. This here, which for all in case and purposes is 0. If we get e to the something bigger than 10, it's just 0. It's a calculation error, and it cancels out. If y'all can go on and head out. And again, if they do have a complaint, tell them to take it up with me.